All right, here we go. A little video on the quadratic formula. Something you should be pretty familiar with. Of course, you need to be in ax squared plus bx plus c form, also known as standard form. You probably learned a little song about Pop Goes the Weasel to help you memorize that. Sing it if you need to. But by now, you should probably have the quadratic formula pretty drained into your brain. So then we have the discriminant. That might be a little bit new for you. The discriminant is just the inside of the radical, b squared minus 4ac. And what that tells us is if you have a perfect square on the inside and it's positive, you will have two rational roots. If you have any other positive number, the discriminant, you'll have two irrational roots. If your discriminant is 0, you will have one rational root. Now, of course, these top three, these are all real numbers. And then if you have a negative number inside, well, you can't take the square root of a negative, well, kind of. And that makes two imaginary roots, okay? So this is pretty much a review video of something you learned back in Algebra 1. So I'll step you through the first one again, and then I'll let you do the next two. So the first one is 2x squared plus x equals 5. The first thing you're going to need to do is make sure you rearrange that to 2x squared plus x minus 5 equals 0. And it's not necessary for me, but if it helps you, you can label your a, b, and c. So your a is 2, your b is 1, your c is a negative 5. And then all you have to do is use the quadratic formula that you know so well. So x is equal to the opposite of b, so negative 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a, which is 2, times c, which is a negative 5. And this is all over 2 times a, which is 1. I'm sorry, 2. So from here, just start simplifying. That's a negative 1 plus or minus the square root of 1 minus 4 times 2 times a negative 5 is going to be a negative 40, which is going to change to plus 40 minus a negative, all over 4. So we have a negative 1 plus or minus the square root of 41 over 4. And that is your final answer because 41 cannot be simplified. The only thing that you might want to do is rewrite that as negative 1/4 plus or minus the square root of 41 over 4, where you split the denominator, or the numerator and the denominator, till you have two separate fractions. That way, in case one of them can be reduced, you'll remember to reduce it. So that's quadratic formula. All you do is plug in the stuff and simplify. So it's your turn. Do number 2 and 3 on your own. So let's see if you got x equals 3 for number 2. Basically, you had to rearrange it first. You need to have 2x squared minus 12x plus 18 equal to 0. Once you have that, this is totally optional, but if you can factor out a GCF of 2, go ahead and factor it out because 2 is not going to have any effect on your solutions. If you factored out a 2x, that totally would. But since you're just factoring out a 2, you can just use the inside. Again, totally optional. You would get the same answer if you did not do that. So then you just plug in your b's, your a's, and your c's, and all that fun stuff, and you're going to get an inside of 0. Now remember, if the discriminant is 0, you're only going to get one rational root. So the square root of 0 is 0, so 6 plus or minus 0 is 6, over 2 is 3, and you're done. Number 3, once you substitute in all of your information and solve, you're going to get a negative 4 for your discriminant, which means if d is negative 4, you're going to have two imaginary roots, which makes sense because the square root of a negative 4 is plus or minus 2i. So you have a negative 2 plus or minus 2i all over a negative 2. Split it and simplify, and you get x equals 1 plus or minus I. And you're done. That's quadratic formula. Remember, this is something that you've done in the past. This should just be a little refresher video. Now here's something a little bit new. I'll show you how to do one, you'll do the other, and then we're done. It's how to find the values of c that give 2 real, 1 real, and 2 imaginary solutions. Now remember, 2 real, that could be rational or irrational. 1 real could be, obviously, rational because 1 real is when you get the discriminant of 0, and then obviously 2 imaginary. So I'll step you through one of them. What you need to do is you just take your discriminant, which is b squared minus 4ac, and you set it equal to 0. And then you plug in your information that you have. So we know that b in this case is a negative 3 squared minus 4 times a, which we know is 2. And we don't know what c is, so we just call him c. And that's equal to 0. So let's start working it out. Negative 3 squared is 9. Minus 4 times 2 is a negative 8. C equals 0. Subtract the 9 to the other side, so we have negative 8c is equal to a negative 9. Divide both sides by a negative 8, and you get c is equal to 9/8. Now, that is when we set the discriminant equal to 0. So that means this guy, 9/8, is when we have one real. So if c equals 9/8, we have one real solution. Now you just need to work yourself the other way. If you have c which is less than 9/8, then that means you're going to have two real. And if c is greater than 9/8, then that means you are going to have two imaginary. Okay, now the reason that worked out is you just kind of have to think about it. If c was a lot bigger, then that would make this second number bigger, which means it would be making this entire thing negative. So that's why if this was negative, that's why you have two imaginary. So you just have to be careful about your thought process there. Okay? So you get to try number 2 on your own. Go for it. So your crucial number this time is negative 4 after you work it out. But this one's a little bit flipped, and you have to, again, think before you answer. C is greater than negative 4. That means two real this time. Okay? It's not less than like the one before. And you could always pick something to guess, or to try. So pick a number that's bigger than negative 4. Say negative 2. And you plug it in. So you have 4 squared minus 4 times a negative 1 times a negative 2, which is negative 2 is bigger than a negative 4. That's going to give you 16. And then you have a negative and a negative and a negative, so that's minus 4 times 1 times 2 is 8. You get a positive number, which is 8, which means you have two real. So if it helps you, pick one and guess. Pick one bigger than this, and, you know, if it works out to be real, then bigger than negative 4 is real. If it turns out to be imaginary, then bigger than negative 4 is imaginary. Okay? But in this case, you know, this is what you should have for your final answer. So that's it with quadratic formula and discriminants. If you have questions, you know where to find me. This is Longo, and I'm out. See you. Bye.